Hiya and welcome to my channel. By the end of the video today, you will have learned how to solve linear and quadratic simultaneous equations using algebra. When you're given linear equations to solve, this is a level 4 or 5 GCSE topic. For non-linear questions, there will be squared terms, and these ones are level 6 or 7 questions. For level 6 or 7, you will also need to solve simultaneous equations graphically, so I'll show you about this as well. You might be wondering what simultaneous equations actually are. Well, simultaneous equations are a set of equations with common values. These values are, for example, x and y that you are trying to find. If the equations are shown graphically, the solutions to your simultaneous equations are the points that the lines cross. Let's look at an example. Y plus x is equal to 15 and 2y take away x is equal to 3. We want to find values of x and y that satisfy both of these two equations. But how do we do that? Well, I'm about to show you that now. So, let's rearrange the first equation to get y in terms of x. That gives us y is equal to 15 take away x. Next, we'll sub this into our second equation and we'll get an equation just in terms of x. That means that we can solve this equation and we can work out the value of x. Rearranging this, we get 27 minus 3x is equal to 0, or 3x equals 27. Dividing this, we get x is equal to 9. Next, we sub this value of x back into the equations to get the value of y, and that in this instance is 6. You can, however, do this in another way. So, you can see our first equation has y plus x, and in the second equation, it's take away x. So if we add the two equations together, we will actually eliminate x and get an equation just in terms of y. Therefore, 3y equals 18 or y is equal to 6. Then if we sub this value of y back into one of the equations and solve for x, then we get x is equal to 9. Our solution is therefore the coordinate 9, 6. So let's look at this on a graph. The point at which these two lines cross is our solution, 9, 6. Here, I plotted each equation by rearranging them to be in the form y equals mx plus c, the equation of a straight line. Now, for an exam question, solve the two simultaneous equations, 4x plus 2y equals 9, and x minus 4y is also equal to 9. Rearranging the second equation to get x in terms of y, we get x is equal to 4y plus 9. Subbing this into the first equation to eliminate x, we get 16y, add 36, add 2y is equal to 9. So let's simplify this down a bit further and then we will get y. So we've added the 16y plus the 2y and then we'll take 36 from both sides. This leaves us with y is equal to minus 3 over 2. Now we'll sub this back into one of the equations and then we can get a value for x. So we've already worked out that x is equal to 4y plus 9, so subbing in this value of y gives us x is equal to 3. Let's look at this graphically. Taking the first equation and rearranging this to be in the form y equals mx plus c, we get 2y is equal to minus 4x plus 9, and then divide by 2, we get the gradient of minus 2 and the y-intercept of 9 over 2. So let's plot this. As you can see, the gradient is negative, and that's why the line is drawn in this way. So, the next equation, x minus 4y is equal to 9, rearranges to y equals x over 4 minus 9 over 4. Now, we can see this has a positive gradient and intercepts our solution, which is 3 minus 3 over 2. Looking at these two equations, we can see x can be eliminated if we multiply the second equation by 5 and then sub it into the first. Multiplying the first equation by 5 gives us 5x minus 15 is equal to 45. Therefore 5x is equal to 15y plus 45. So now let's sub that into the second equation. Substituting 5x as 15y plus 45, we get 16y plus 45 is equal to 21. Now, let's take our 45 from both sides and then divide the equation by 16. That gives us y is equal to minus 24 over 16 which is just equal to -3/2. Subbing this back into the equation to solve for x, we get x minus 3 all multiplied by -3/2 is equal to 9. Simplifying this down, we get x is equal to 9/2. The coordinate then that our two lines cross at is 9/2 minus 3/2. So let's look at this again on a graph. To plot the equations, you'll need to rearrange them again to be in the form y equals mx plus c. This is what they look like. And you can see that they do in fact cross just at the one point. Next up, we've got a more tricky version of nonlinear simultaneous equations. So you'll see the first one there, 2x squared minus y squared, has got squared terms. We'll start by rearranging the second equation to get x is equal to 1 minus 2y. Subbing this into the first equation, we can eliminate x, and we're left with 2 multiplied by 1 minus 2y all squared minus y squared is equal to 17. So let's expand out the brackets and simplify this down further. Here we've got 2 minus 8y add y squared take away y squared is equal to 17. So we're left with 7y squared minus 8y add 2 minus 17 is equal to 0. Or 7y squared minus 8y minus 15 is equal to 0. So what we need to do is we need to use the quadratic formula to work out the two values of y. So we'll get y is equal to minus -8 plus or minus the square root of minus 8 all squared minus 4 times 7 minus 15, all divided by 14. Simplifying this further, we get y is equal to 8 plus or minus 22 all divided by 14. So the two values of y are y is equal to 15 divided by 7 and y is equal to minus 14 over 14, which is just equal to -1. So the next thing we need to do is find the corresponding x values for both y values. We will tackle these both separately. So let's start with y is equal to 15 over 7. Subbing this into the second equation, we get x plus 2 multiplied by 15 over 7 is equal to 1. So x is equal to 1 minus 30 over 7, which is equal to minus 23 over 7. Our first coordinate the two equations would cross out on a graph is therefore minus 23 over 7, 15 over 7. Looking at the second value of y and subbing this into the second equation, we get x minus 2 is equal to 1, so x is just equal to 1. Therefore the second coordinate the two lines meet at is 1, -1. This exam question requires you to solve the two simultaneous equations and find where the lines meet before finding the midpoint of these 2 points. Rearranging the second equation, we get that y is equal to 6x. So now subbing this into the first equation, and we'll expand the brackets, we get 6x is equal to 10x squared minus 3x plus 10x take away 3. So rearranging this further, we get 10x squared plus x minus 3 is equal to 0. So we're going to have to call on the quadratic formula again. We'll get x is equal to minus 1 plus or minus the square root of 1 minus 4 times 10 times -3 all over 20. Here we get x is equal to -3 over 5 or x is equal to a half. So we'll take these values and sub it into the equation y equals 6x to get the two values of y. Here we get y is equal to -18 over 5 or y is equal to 3, and therefore we've got our two coordinates of the points A and B. Now we just need to find the midpoint of the line AB. To work out the midpoint, we'll take the x coordinates first, add them together and then divide them by 2 to find the average of those ones, and then we'll do the same with the y value. So the x value, we get this to be minus 11 over 20. Summing the y coordinates, -18 over 5 and 3, we get the value to be -18 over 5 plus 15 over 5, all divided by 2, which is -3 over 10. Therefore, our midpoint is the point minus 11 over 20, -3 over 10. Now, I don't know whether you noticed through the questions from the exams that actually the answers weren't particularly nice, so don't get put off when you're answering these in the exam. Always remember to check your answers or do the question twice, and then if you're happy with it, then stick with it. Don't doubt yourself just because you've not got whole values. Thank you for watching my video. If you found the content useful, please like and share. Comment below with any topics that you want me to cover, and don't forget to subscribe to my channel.